Today we are looking at multi-material 3D printing. I have several projects we're going to go through today to look at what does and does not work when it comes to multi-material 3D printing. First up will be a coaster. I have a version with and without the Widget KC logo for you, a water-resistant box with a TPU seal, and a pair of curvy sunglass frames. You can check out the description below if you want to try any of these projects yourself. Let's take a look at the final coaster design. We used white PLA matte for the main body and then inlaid some shiny PETG green and black to contrast nicely with the logo. On the back, we used TPU for the feet to prevent scratching or sliding on the tabletop. What did I find out that didn't work great on this print? Well, PLA and PETG do not bond at all. My first coaster had the materials going all the way through and simply came apart when removing it from the print bed. The TPU bonded a little bit better to the PLA. It might be good enough for the coaster. So what did I do to resolve the issues? Well, I made the back of the coaster solid PLA so that the PETG would only be able to come out in one direction. I also printed the coaster face down on the print bed so there would be some mechanical interlock between the PETG and PLA, basically squishing the materials together. I left the TPU as is, thinking it's probably good enough for the coaster. I wonder if there is a better way, though, than just leaving it as is. There is, and we'll get to that in our next project, the water-resistant project box. The project box is made of white PLA matte with TPU 90A inserts, such as this gasket and the sidewall. The two sidewalls have the TPU section, so you can basically drill holes in these sidewalls, fish wires through, and still have some amount of waterproofing to your enclosure. I designed channels into the box to firmly hold the TPU in place. Remember, we found out in the coaster project the TPU doesn't bond great to PLA. Stick around though, because there's something even better and easier than designing in these channels. So what didn't work well with this project? TPU for AMS is a little bit stiff and didn't produce the best water seal. I actually got some water intrusion in my waterproofing test. So I switched over and used TPU 90A instead. In that case, the waterproofing test proved that there was no water intrusion into the project box itself. There are specific needs to be able to use TPU 90A on the Bambu Lab H2 series printers. If you're interested in seeing that, hit that subscribe button. I'm working on a video that goes through all about TPU with these types of printers. That video will also go through a couple of examples of TPU so that you can better choose which one might be more applicable to your project. A tangent here, this project box is a great example of the benefits of multi-material printing. I get a box with different properties, the rigid PLA and the soft TPU gaskets in one print, and I didn't have to design an assembly process to get that TPU and that gasket fitted on there, and so I ended up with a nice clean project box, no assembly required. But there's more. I promised you a way that might be even simpler to allow multiple materials that don't bond well together to still interlock and stay together. And there is in Bambu Studio. Let's take a look. The feature is called beam interlocking. You can find the beam interlocking feature by toggling advanced on, clicking on the others tab, and then scrolling down to the bottom where you see the use beam interlocking. If you select that and leave the defaults in there, what you can do is go ahead and slice the plate and see what beam interlocking does. So you can see here that it actually adds crosshatches to these TPU feet, where ordinarily the TPU would just be stuck to the white PLA. You now have crosshatches that are going back and forth to help solidify that TPU into the PLA. If we go further into our print, you'll also see the same behaviors on the logo towards the front of the coaster, where crosshatch patterns mechanically lock the different types of materials, in this case PETG and PLA, together so that they can't come apart. This worked exceptionally well for the coaster project in today's video. It worked pretty good for the project box. One caveat with beam interlocking is that you can't yet specify which materials you do or don't want to beam interlock. If you explicitly don't want some materials to beam interlock, you can't yet specify that in Bambu Studio. Next, let's look at the sunglasses. I kept losing and breaking my sunglasses, and so I decided to design this pair so I could just print off a new pair, snap in some lenses, and I'd be good to go. For this example, we don't use dual material inside the print. We actually use dual material to support the print because of the complex geometry of the sunglasses. For these sunglasses, we used PAHT carbon fiber as the frame material, and then we used ASA to support that during the print. The frames have a built-in hinge, so all you have to do after the print is complete is take them off the print bed, remove the support material, pop in some lenses, and the sunglasses are ready for use. Like other projects, it wasn't all rosy getting to this point. So what didn't work well? I tried PA support material, which is supposed to be dedicated support material for PAHT. The problem is it worked well, but bonded a little bit too well to the PAHT carbon fiber. Because it was green, you're left with green flakes on the final print. I tried ABS frames with dedicated ABS support material because ABS also has some temperature tolerance, but you can see how even after removing the support structure, the ABS support material did still stick to the ABS. It wasn't a super clean removal, although it did work slightly better than the experience that I had with the PA removal from the PAHT carbon fiber sunglasses. What did I do to resolve these issues? Well, I went back to PAHT carbon fiber because I do like the finished look of that. It hides the layer lines, has great temperature tolerance, and ultimately has a good strength quality to it. So I searched online and found some folks were using ASA as support material. A point about the dedicated support materials. They aren't intended to be used as support structure. They're just supposed to be a thin layer between the object that you're printing and the larger support structure that's holding it up. ASA is different in that you could potentially print the structure and the interface layer in ASA and then your object in something like PAHT carbon fiber. This is great because PAHT carbon fiber is generally more expensive than ASA, and so you can print quite a bit of support structure for very cheap, as opposed to printing that support structure out of PAHT carbon fiber. The only question is, does ASA work for PAHT carbon fiber support? And yes, it does amazingly well. ASA was able to hold the print in place, and after the print was complete, almost falls off of the PAHT carbon fiber. From this point on, I don't see a need for the dedicated PA support material for any PAHT carbon fiber printing I do in the future. I'll just stick with ASA. Another benefit is the ASA is black like the PAHT carbon fiber. If there's any small amounts left over on the sunglasses, you won't be able to see those. If you like this video, we have a lot more to talk about. Hit that subscribe button and look forward to more multi-material videos in the future. Thanks for watching, and God bless.